Hi, students, and welcome to our June 16th lesson. Today, we're going to talk about some projectile motion problems. We have a do now prompt first. I'd like you to start with that. And then we'll do those projectile motion problems. And our assignment is the 2 pages, as you'll see. Remember, you're working through those digital escape rooms, A through H. None of them should be locked. I shouldn't be receiving any emails about something you couldn't get into. Don't send me a sharing thing that doesn't work. Go back into your teams. All the links were tested 2 days ago. They should all be fresh and they're all functional. So write to me if you have any problems with that. If you are a distance learner today, you'll need to upload copies of your pages. And if you are in class, I'll need to see those completed pages. And there's some work there if you are finished. Remember, all the escape rooms are due Friday. Look for a summary document in Teams for you to put everything into. So I'm going to leave you to the do now yourself. I want to get right into these projectile motion problems. So first we have a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h equals negative 16 t squared plus 90t gives the height h, so h is the height of the ball after t seconds. And h is going to very much function like our y that we usually have, and t is very much going to function like the x that we're used to when we've done our quadratics. So first we're asked to find the maximum height of the ball, and then we're asked how many seconds it will take for the ball to reach the ground. So when we're asked to find the maximum height of the ball, what we need is the vertex. So remember, it's kicked from the ground, so somebody is here, and they kick this ball from the ground. It goes up, and then it comes down. And this is the ground. So when they ask what the maximum height is, here we're talking about the vertex. In order to find the vertex, the first thing we're going to need is the axis of symmetry. Remember that? So we're going to use the formula negative b divided by 2a. So we're going to find the axis of symmetry. Negative b divided by 2 times a. So our b value here is 90. So we're going to have t equals negative 90 divided by 2a, 2 times negative 16. And when we simplify that, that's negative 90 over negative 32. We'll continue to simplify that. And we're going to work in decimals today because we're working with height, and it just will work out better. So when we simplify this to 2 decimal places, it will be approximately, t will be approximately 2.81, but we're not there yet. So we've found the axis of symmetry. Now we need to find the vertex. So we're going to substitute the axis of symmetry for t in this formula. So h equals, so we'll get the y value. Remember, this vertex here has an x value and a y value. The y value is the height. So we've got our x value here, 2.81, or what we're calling t in these problems. So to find the height, we need to find the y value. So we're going to substitute this 2.81 into this equation that they've given us. So h equals negative 16, use parentheses, 2.81 squared plus 90 times 2.81, and this is where the good calculators will really help you. We're going to get this in 2 decimal places, and when we evaluate this, it equals approximately 126.56, and what we're talking about here is feet. So 126.56 feet. Now we're asked, how many seconds will it take for the ball to reach the ground? So at this point, if we want the ball to reach the ground, we're going to take the equation that they've given us, negative 16 t squared plus 90t, and we're going to set that equal to 0, because 0 is the height of the ground. So let's do that now. Negative 16 t squared plus 90t, and we'll set that equal to 0. Let's factor out a 2 and a t to make this simpler. So we factor 2t out of negative, let's factor out a negative 2t. And if we factor out a negative 2t, we're going to have 8t. If we factor negative 2t out of 90t, we're going to have minus 45 equals 0. Let's change our color so we can solve this. So negative 2t can, when we evaluate that, it's going to be 0, and so t cannot equal 0, because we cannot have this thing go from this point being kicked up into the air 126.56 feet and back down in 0 seconds. So that's a throwaway answer. But let's set 8t minus 45 equal to 0. And when we evaluate that, t will be equal to 5.625. And this is after t seconds. So the ball will hit the ground in 5.625 seconds. So let's try another one. Now we've got an apple that's launched directly upward at 64 feet per second from an 80-foot tall platform. The equation for the apple's height, h, at time t seconds after launch is h equals negative 16t squared plus 64t plus 80. So first we want the maximum height. So we're going to have to use the formula for axis of symmetry. T equals negative b divided by 2a. So our b is 64, so negative 64 divided by 2 times negative 16, which will simplify to negative 64 over negative 32, which simplifies to 2. We'll insert 2 into this equation and solve for h to get our height. So h equals negative 16, we substitute the 2, squared, plus 64, we substitute the 2, plus 80. And when we evaluate that, that equals, our h equals 144. And we're talking about, so that now the height of the apple is 100, at the highest height of the apple, okay? Remember, here's the apple. It's launched directly upward, 64 feet per second from an 80-foot tall platform. So let's redraw that. And since it's an apple, let's use red. So we've got an 80-foot tall platform, and we're launching the apple straight up, and then it eventually is going to come down and hit the ground. So first we found the vertex, the maximum height, and we found that to be 144 feet. So the next question is, how many seconds will it take for the apple to reach the ground? So we're going to take our original equation and we're going to set that equal to 0 and solve for t and see how many seconds. So here we go. We've got 16t squared plus 64t plus 80, and we set that equal to 0. And let's factor out a 16. So that will give us a 16, and inside the parentheses, t squared plus 4t, minus, let's factor out a negative 16. I forgot my negative sign at the beginning. So let's factor out a negative 16. So t squared minus 16, 64 divided by 60 minus 4t minus 5 equals 0. Okay, let's keep on working. So let's factor t squared minus 4t minus 5. We need two numbers that add to negative 4, multiply to negative 5. So that would be negative 5 and positive 1. So we have negative 16, x minus 5, x plus 1 equals 0. And let's solve and see what we have for an answer. So negative 16 cannot equal 0, so that's a throwaway answer. Then we have t, I wrote x, but these are t's. Such a habit. So t equals, here, if t minus 5 equals 0, t equals 5. And here, if t plus 1 equals 0, t equals negative 1. So that's a throwaway answer. That answer is not going to help us. So we've got t equals 5. So that's how long it's going to take, 5 seconds, for this apple to go from here down to the ground. 5 seconds. Okay, number 3. In science class, students were asked to create a container to hold an egg. Then they would drop this container from a window to this 25 feet above the ground. If the equation of the container's pathway can be modeled by the equation h equals negative 16 t squared plus 25, how long will it take for the container to reach the ground? So they're dropping it from a window. Here they are at the window. They've got this container. It has an egg inside. I guess they're experimenting to see if the egg will break. Here's the ground. Sometimes a diagram helps. So here's the kids. They're dropping this container. They're happy. And this thing is going to drop to the ground. Boom. So we want to find the maximum height of the container. Well, remember, they are not throwing it up anywhere. Okay, so in that sense, you look at this equation, we have no b value, okay? We have our squared value, we have our a t squared. You know, if we have a standard form of an equation, ax squared plus bx, it's a quadratic equation, plus c. Okay, we've got the a value, we have a c value, but we don't have a b value. There's no b value. So if there's no b value, the b equals 0. So when we try to find the vertex, we have to use 0 as the b value. So t equals, negative 0, where 0 is neither positive nor negative, divided by 2a, that equals 0. So now we take 0 and we substitute it into this equation. H equals negative 16. Instead of t, we have 0 squared plus 25, and it's real easy to evaluate. That equals 25. So the maximum height of the container is this point right here in the drawing. That's the maximum height. And that height is 25, which makes sense because they tell us they're dropping the container from a window that's 25 feet above ground. So I don't know if anybody figured that out, that we actually didn't even need to do any math, but we got some good practice. So the maximum height is 25 feet. Now, how many seconds will it take for the container to reach the ground? So now we're going to set this equation equal to 0. Negative 16 t squared plus 25 equals 0. And if we divide 25, well, first of all, I think what we want to do is move 25 over to the other side. So negative 16 t squared equals negative 25. If we divide them both by -1, let's just get rid of the negative signs. Okay, so now what we have really is 16t squared equals 25. Now we're going to divide both sides by 16, and we like this because 25 is a perfect square and 16 is a perfect square. So now we have t squared equals 25 over 16. Now we're going to take the root of both sides. And when we do that, we have t equals 5 over 4, and that's plus or minus 5 over 4. However, because this is a distance problem, the negative is not going to help us. We don't need the negative in this case. So t equals 5 over 4. Let's convert that to a decimal. 5 divided by 4 is 1.25, and we're talking about seconds, so that would be 1.25 seconds for that thing to reach the ground. Okay, moving on. Now we've got the Empire State Building problem. A penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation h equals negative 16t squared plus 1,250, how long would it take the penny to strike a 6-foot tall person? Okay, a couple of things you need to know about this. When we say 6-foot tall person, okay, this will be our 6-foot tall person, 6 feet. And what we're talking about is it landing on the top of the person's head, right there. So now we're going to take this equation, this negative 16t squared plus 1250, and we're going to set it equal to 6. And the first thing we want to do is subtract 1250 from each side. So then we will have negative 16t squared equals 1,244. And let's divide both sides by negative 16. I think I'll change my color here. And then we have t squared equals, we have a negative, oops, this is negative. We have a negative divided by negative, so that will be positive. So t squared equals 1,244 divided by 16 is 77.75. And students, this is really where you want to use a calculator. And you can use the calculator function. So the square root of t squared is t, and the square root of 77.75 is plus or minus 8.82, We're going to omit the negative. We are talking about distance, we're talking about time, which cannot be negative unless we're in a science fiction movie. So the answer is 8.82 seconds. We're dealing with seconds. So if you drop a penny off the top of the Empire State Building in 8.82 seconds, if a 6-foot tall person is standing under there, you're going to hit them in the head. And it'll be pretty hard. And when you get to physics class, you'll probably talk more about the impact of that penny and the force of that penny. All right, let's move on to number 5. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height, h, at the time t seconds after launch is h equals negative 16t squared plus 80t. How long will it take the fireworks to reach the ground? So we don't want to know the maximum height. We're not being asked that. So we don't need to know the vertex. We don't need to take negative b and divide it by 2a. All we want to know is how long will it take the firework to reach the ground? So we just set it equal to 0, negative 16 t squared plus 80t equals 0. And let's factor negative 16t out of this equation. So let's change our color. We're factoring out negative 16t, which leaves us with t minus 5 equals 0. And now we can easily solve this. So we don't like t equals 0. That answer doesn't work for us. But t equals 5 certainly works for us. So that means it takes 5 seconds for that firework to hit the ground. Okay, roller coaster. We should probably get the details on the roller coasters at Lake Compounds, and we can do some math with them. But this one's a Busch Garden roller coaster called the Apollo's Chariot. So the Apollo's Chariot, a roller coaster at Busch Gardens, moves at 101 feet per second. So they're telling us the speed. The equation of the ride can be represented by the equation h equals negative 16t squared plus 101t plus 10. What is the maximum height reached by this ride? So first we're going to use our negative b divided by 2a. So our b value is 101. So negative 101 divided by 2 times negative 16, which simplifies to negative 101. Sorry, put a 0 there. I needed to put a 1. Divided by negative 32, which simplifies in decimals to approximately 3.16. Now we're going to substitute that into the equation, substituting it for t in both places. So h equals, so we want to find the vertex, the y value, or in this case, the h value of the vertex. So negative 16, substituting that 3.16. Okay, I'm just following the formula, plus 101, did it again. And we substitute 3.16 plus 10. Use a good calculator. And when you do that to the 2 decimal points, that is approximately 169.39 feet. The maximum height reached by that roller coaster is 169.39 feet. And we're on to number 7. And number 7 is about Eva, who's jumping on a trampoline. Her height, h, at time t can be modeled by the equation h equals negative 16t squared plus 20t plus 6. The question is interesting. Would Eva reach a height of 14 feet? So when we evaluate, we need to have an answer of 14 or greater because it's would she. So it's going to be yes or no. And we could probably give some additional data. So first we need to find what we normally call the x value in the vertex. So we're going to do our negative b divided by 2a. So in this case, we're calling it t equals, so our b is 20, so negative 20 divided by 2 times negative 16, which simplifies to 20 over 32, because negative divided by negative is a positive, which simplifies in decimal terms to 0.625. Let's substitute that into our equation. H equals negative 16, 0.625 squared plus 20 times 0.625 plus 6. And when we evaluate that, it equals 12.25. So 12.25 feet is the maximum height that Eva can jump. The question was, would Eva reach a height of 14 feet? The answer to that question is no. The maximum height is 12.25 feet. And then finally, I believe it's our last problem for the day, an astronaut on the moon. All right, how do we even know this is true? An astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the baseball 2 meters above the ground. So here's where our astronaut, he's tossing the ball, he's letting go of it right there. And the distance between here and the ground is 2 meters. So he's letting it go at a distance of 2 meters above the ground. Now we have an equation. The equation of the baseball pathway, okay? He's letting go of it. It's going to go up. It's going to come down. It is modeled by the equation. So here's the moon equation. H equals negative 0.8 t squared plus 10t plus 2. So here's our moon guy. Well, it looks like we also have an Earth guy. The same experiment is done on Earth. Maybe it's a woman doing it on Earth, in which the pathway is modeled by the equation H equals negative 4.9 t squared plus 10t plus 2. So somebody's doing it on the moon. Meanwhile, somebody's doing the same thing on Earth. There's their baseball. And they're throwing it up, and it's going to come down. All right, same experiment, once on the moon, once on the Earth. Now, here's the question. How much longer would the ball stay in the air on the moon compared to on Earth? So they're already telling us our moon answer is going to be larger, greater than our Earth answer. So let's do the moon first, and then we'll do the Earth. Let's do the moon in the darker color. Let's see, here we go. So we'll do the moon first. So we're going to use the quadratic equation for this. This has already got decimals in it. So we're going to use t equals negative b, so that would be negative 10 plus or minus the square root of b squared minus 4ac, so that would be 10 squared minus 4 times negative 0.8 times 2, and all of that over 2 times a. And when we start to evaluate that, t will equal negative 10 plus or minus the square root of 106 divided by negative 1.6, and so t will equal, let's keep evaluating. We can simplify that to, if we take, I'm going to use the highlighter to show you this. We're going to divide negative 10 by 1.6 to get our plus the square root of 106, and negative 10 divided by 106, divided 1.9 plus and minus our 106. So first our minus answer, okay, our negative answer is negative 0.20. Okay, we can't use that answer. We're going to cross it out. Our positive answer is 12.70. Okay, so it's negative 10 divided by negative 1.6 plus the square root of 106. So our positive answer is helpful to us. So that's the moon. How long will it take this thing to hit the ground on the moon? Now we've got to do the Earth. Again, we're going to use the quadratic equation. T equals negative 10 plus or minus. So we're using the Earth equation. So we have slightly different numbers. So we've got the square root of 10 squared minus 4. Now we have a different a value. We've got negative 4.9. And our c is 2 divided by 2 times negative 4.9. And let's simplify that. T equals negative 10 plus or minus the square root of, and if we evaluate all this in the numerator, that would be 139.2. And then our denominator would be negative 9.8. If we continue to evaluate it, if we evaluate the negative 10 minus the square root of 139.2 divided by negative 9.8, the answer we get will be t equals negative 0.18, and that answer cannot be correct, so that's our throwaway answer. And if we evaluate negative 10 plus the square root of 139.2 divided by 9.8, our answer will be 2.22 seconds. Now let's go back to the question. How much longer? Okay, so we have to subtract the Earth from the moon to find out how much longer. So the moon time is 12.70 seconds. The Earth time is 2.22 seconds. And we subtract those, we have 10.48 seconds. So how much longer? 10.48 seconds longer, or seconds more on the moon, the ball will stay in the air. So those are some pretty interesting problems. You've got some extra activities you can do if you finish early, but this should get you through your quadratic escape room H, and you should be good with that. So I'm proud of how hard you're working. I want you to keep working hard. Remember always to be kind to others and help each other with their math, because with practice, you'll be great.